I am going to show you this simulator in the single engine piston configuration. Let's take a seat. Fasten your seat belts. There is the shoulder harness, two ends of the shoulder harness and the end of the seat belt. I suggest to use the armrest so you will be able to control the aircraft smoothly and to make small corrections. Next to the throttle quadrant there is the emergency stop, up, and switch is going to release the pneumatic air and cut the electricity. There is another emergency cutout here on this panel behind the simulator. You should push this button to stop the pneumatic and electricity. Let's discuss the systems inside. Left hand side there is outside air temperature calibrated in degrees Celsius. Next to it we have the holder for the checklist. Left hand side behind the yoke we have a mic normal oxygen mask switch, which is not used in this type of the aircraft. We have the avionics master, which is called radio master in the aircrafts. We have the master switches, the battery and generator. Let's turn on the battery. As we turn on the battery we have electric power, generator and low oil pressure annunciators are illuminated. There are left and right magnetos. We have a starter button and an electric primer. This ignition section is not used in this aircraft. This is the parking brake. To release the parking brake you should pull and push. To set the parking brake first you have to apply manual brake, and then when the pressure is increased pull out to set the brake. Right side of the yoke there are the light switches. We have panel light, instrument lights and the floodlight, beacon light, nav light, wing light, taxi light and two landing lights. Just below the taxi light there's the pitot heat switch. The gear is not used in this aircraft. To be able to start the engine we need to open the fuel tanks. This is the left tank. Open, close. This is a safety switch, you should pull it first and then switch. This is for the right tank. The right tank is closed in the center position and open in the left position. Closed, open. We have the standby fuel pump, still safety switch. You can hear the sound of the operating fuel pump. Let's check the instruments. We have to turn on the avionics master. Now we can turn on the avionics. Radio panel, GNS 430, COM2 and NAV2, ADF and the transponder. Please turn on the standard transponder in the mode you want to turn it on. In our case it's standby. DME. After the GNS is started, check the aviation database expiry date and press OK. This is the instrument self-panel test. Press OK. The audio panel is solely for audio purposes. You can set the volume of the intercom. Co-pilot can set the volume of his intercom. The inner knob is for the squelch. If you don't know what squelch is and how to use, please check the manual for GMA 430. Marker mute, sensitivity, marker sensitivity high or low. To select communication, you can select COM1, COM2, COM3. You can listen simultaneously more than one communication frequencies, but you can only transmit one on the same time. Now COM1 is selected for communication and for listening as well. COM1 is on the GNS. You can select the standby frequency. Let's select Nyíregyháza 119er. And put it to the active. Now we are communicating on Nyíregyháza frequency. I suggest to set the communication volume, you can see the small dot there, at around 1 or 2 o'clock position. COM2 is the bendix. The left side of the instrument is used for communication. This is the COM2. You can set the volume here, change the standby frequency. Let's turn to Nyíregyháza 119.410 to set 8.33. You should pull the knob, push it back again, and you can change to the active. To be able to initiate communication, you have the push to talk button on the back side of your yoke, left hand side. And when it's pushed, you can see the TX appears, transmitting. For navigation we can use nav1 on the GPS or nav1 on the bendix, which is the right side of the instrument. Let's set 116.1 on the GNS. Which is November Yankee Romeo VOR at Nyíregyháza. So 116.1 is set on the standby, so make it active. To identify the Morse code, first set the volume to minimum to counteract the potential hearing loss due to the high volume. Okay, so select the nav1 on the audio panel because we want to listen the Morse code. Push this button, you see ID appeared, and turn the volume, but never more than the top side. I suggest that 10 o'clock position is good enough. And if you can't hear, wait a bit, because between two Morse codes there's a short break. Check if the Morse code corresponds. And turn it off. And turn the volume back down again. Let's do the same on nav2. Set 116.1 November Yankee Romeo. With this button you can change it to active mode. Check the volume is down. Set nav2. And written here, pull to ident. This should be pushed, this should be pulled. So pull and turn. I suggest the 10 o'clock position again. And wait. Sometimes we have a delay. If we identified it correctly, then turn it off. So this is how to identify on nav1 and nav2. Our next instrument is the ADF. You can see the active and the standby frequency. Let's set Papa Quebec 522. 5, 2, and pull out 2. Set. Here is the frequency change button. Put it to active mode. And don't forget, you have to identify it, so turn the volume down, and after you select the ADF you are going to hear the Morse code. You don't have to pull or push anything, or you don't have to change the volume. If it's correctly identified, turn it off. The ADF can be used for timer function as well. To set the timer, push the FLT-ET button. Flight time, if you push it one more time, elapsed time. Flight time shows the time since the ADF was turned on. Elapsed time can be reset by this set/reset button. So we use this primarily for timing. To go back to show the frequency, you should push the frequency button again. We have some extra function on the audio panel. One of that is COM12, which gives the possibility to communicate on COM1 and COM2 on the same time. Left seat pilot communicates on COM1, right seat pilot communicates on COM2. Speaker let us to hear the communication on the speaker. If we have headset, speaker is not required. If we have no headset, speaker will be required. PA is passenger advisory. If we have passengers and you want to talk to them, you can talk to them via passenger advisory. Pilot and crew isolation isolates the pilot, the left seat pilot, or the crew, left seat and right seat pilot, from the rest of the passenger communication. So if we have two passengers on the backside and we want to communicate to the ATC, but the passengers want to communicate to each other, we can isolate ourselves. And there's the test button to see if every single light is working. The DME measures the distance from the DME station, which is usually co-located with VOR or ILS localizer. You can select N1, which is navigation 1, hold, or nav2, which is navigation 2. In our case, 116.1 is selected on nav1, and I set 110.1 as well for later. So we are now measuring the distance from 116.1, which is the nav1. If we want to measure the distance from the nav2, we can change to nav2. You can see 2 is there in case of 1. 1 is there. If I change the frequency on nav1, it's instantly changed. What if I want to change the frequency, but I don't want to change the reading here? That's why we have the hold. If you turn to hold, H appeared here, so 1 hold, it holds the 1. From N2 you change to hold, hold 2 appears. What does this hold do? 116.1 there, I set to hold, and even if I change the frequency, it still measures the distance from 116.1 because it holds. Let's take a look on the instrument panel. We have a conventional airspeed indicator. The artificial horizon of the pilot is electrically driven. So as soon as you're turning on the battery, the left seat pilot's artificial horizon going to start to work. The right seat pilot's artificial horizon is vacuum driven. We have an altimeter, vertical speed indicator, directional gyro. You can set the heading bug with this knob. The heading bug should always correspond to our heading. We have a turn coordinator, and we have a CDI and an RMI. So let's take a closer view. What does the CDI do? CDI is the course deviation indicator. It shows our course deviation. The left seat pilot's CDI is connected to nav1. What is selected on the GNS? Right seat pilot's CDI connected to nav2 Let's take a closer look on the RMI. The RMI is rows moving automatically. It always corresponds to our heading. The yellow needle shows the ADF. Now it's 346. If I change to 522, the indication is going to change. The green needle shows the VOR radial, and the source can be selected next to it on the switch. ILS not working on the same principle, so RMI green needle can be only used for VOR or later for GNS use. Let's check the engine instruments. We have an RPM, oil pressure and oil temperature indicator, fuel pressure indicator, fuel in tank, left tank, right tank, and flap indicator. Just below the avionics we have the gyro section. If you don't know, please review which are the gyroscopic instruments and how does the pressure instruments work. We have a throttle, condition lever, conventional trim. Normally, if the trim is set for 4 units for takeoff, it's going to be sufficient. We have an electric trim. You can move the trim by this button, pitch down, push forward, pitch up, move backward. We still have an aileron and rudder trim. I suggest to keep it on 0 position. Right seat pilots has the same instruments. The only difference is the CDI is on F2 and the artificial horizon is vacuum driven. Right seat pilot has an RMI source as well. Behind the right yoke we have the circuit breakers. Circuit breakers can be pulled out, and it's clearly visible it's out because it has a white mark on it. If a circuit breaker pops out, you should wait for cooling and then you can push it back only once. If the circuit breaker pops out one more time, you must not push it back. If you want to stop a system, let's say you have a trim runaway, you can counteract the trimming by pushing the red button on your yoke, and then by pulling out the elevator trim CB, right of the CBs we have the alternate static port. This is in the safety switch, so you can't switch it unless you lift the safety. Alternate static port open, alternate static port off. In this simulator we have 3 annunciator lights. You can press to test only the light bulbs of the annunciator lights. One annunciator light is illuminated when the oil pressure is low. The generator annunciation is illuminated when the generator not produced enough electricity for the systems. And the ignition on is illuminated when the starter is still engaged. Normally, the upper scale, the load meter is active. It shows the generator load in percentage. 0, 0.5, 1 means 100%, 50%, 0%. So now the electricity produced by the generator is about 10%. The generator has a maximum capacity, so you can calculate the current in amperes produced by the generator. Let's say the generator capacity is 60 amperes. If it works on 10%, the electricity produced is 6 ampere. What if I turn on the generator? shows 0 because the generator not produce any electricity. And generator light is illuminated. The second scale is voltmeter. It shows the bus voltage. Now you can see the bus voltage is 27-28 volts. The generator produces 28 volts. If the generator is on, the generator voltage can be seen on the bus. If the generator is off, it shows 24 volts normally, which is the battery. The battery produces 24 volts.